Good morning students, welcome to online class D1 Nalgonda. Today we are here to learn about the structure of atom, 6th lesson, 10th class lesson. We have already learned about the subatomic particles in the atom. We have acquired the fundamental ideas about the atomic models, J. Thomson atomic model, Rutherford atomic model, Niels Bohr atomic model. So in this lesson, what we will learn in this lesson means the drawbacks of Niels Bohr atomic model. To overcome the drawback of Niels Bohr atomic model, Bohr Sommerfeld atomic model is there. So before that one, first we have to know the terms spectrum. The spectrum is a scientific word. It is used to describe the rainbow formation. So the rainbow is there are the 7 colors in rainbow with ZR. Okay, violet, indigo, blue, green, yellow, orange, red. These 7 colors varies with their intensity. So the continuous spreading of these colors in the rainbow. So the colors formation differs with their intensity. So this continuous spreading is considered as a spectrum. So the light, before that one we have to learn about the wave nature of light. The sun emits the electromagnetic waves. All waves varies with their wavelength and energies. Okay, so these waves are formed by the electric field and magnetic field. So suppose when you throw a stone into the still pond, so what we get? We observe the ripples which are transmitting the disturbances from one place to another place. We called as they are the ripples in the pond. So similarly, the sound waves is also the sound is also vibrating. If any object is vibrating, so it is produces the sound. So similarly, the light is also produce the waves in the form of electric field, the combination of electric field and magnetic field. So if vibrates the electric charge, it creates a electric field and magnetic field. That electric field and magnetic field is perpendicular to each other to formation of wave, electromagnetic wave. So if suppose the electric field and the magnetic field, okay, these two are the perpendicular to each other, and this one is magnetic field to the propagation of wave. So the electromagnetic wave is the propagation of the perpendicular of electric field and magnetic field. So this combination of electric field and magnetic field, it generates electromagnetic waves. So all light rays are moving in a wave. So wave has a characteristic terms. What they are means wavelength. Okay, wavelength is denoted with lambda. Okay, what is wavelength means? The distance between from one wave peak to another peak. Okay, for example, here you see okay, here what is the wavelength means? The distance from this point to this point. The 2 successive crusts and 2 successive troughs distance is considered as a wavelength. This wavelength is we have to denote it with lambda. So wave has a wavelength, it's denoted with lambda. The distance from one wave peak to the next another peak, it is considered as a wavelength. Next one, frequency. Okay, frequency is denoted with mu. The number of waves passing through a point per unit time. Okay, number of waves passing through a point per unit time, it's considered as a frequency. Okay, for example, you see here a point is there. So here wave, how many waves completed to, how many waves are crosses this point, that number of waves per unit time, how many waves are crossing this point, that is considered as a frequency. So there is a relation of frequency to wavelength. So what is the relation of frequency to wavelength means, for example, you see here point is there, this one is the small wavelength wave and this one is the big wavelength wave. In these two cases, small wavelength wave is moving more number of waves passing through this point per unit time, more wavelength wave is moving through this point, more number of waves is here, more wavelength is there means slowly moves passing through a point. So here less wavelength, here more wavelength, per unit time here less number of waves is crosses this point, per unit time these waves are less number of waves are crosses this point. So small wavelength is there, more number of waves cross this point per unit time, more wavelength is there means less number of waves cross this point per unit time. So this is the relation of wavelength and frequency. The wavelength and frequency are inversely proportional to each other if lambda is inversely proportional to frequency. So more wavelength is there means frequency is less. Why? Because less number of waves passes through the point. Wavelength is more, wavelength is less, more number of waves is passes through a point. So this is the universal relation for all the waves. Okay, and if you remove the proportional, you keep the constant, that is the c. C is the velocity of light. Three into 10 to the power of 8 meters per second. Okay, and c equals to lambda per mu. Electromagnetic waves are gamma rays, X-rays, UV, visible, IR, microwaves, radio waves. Okay, these are varies with their wavelength and frequency. Okay, so here the visible region from 400 nanometers to 700 nanometers, this wavelength waves are we can perceive our naked eye. So that's why here the Ibziar colors are we observed for our naked eye. So it is the visible region, it is the visible light. So this is the UV rays and this is X-rays and gamma rays and IR micro radio waves. This wavelength is increases from gamma to radio waves. Okay, so this is considered as the electromagnetic spectrum. Okay, so it is entire the range of wavelength contains the electromagnetic waves. This is considered as the electromagnetic spectrum. At the range of 400 nanometers to 700 nanometers, the Ibziar visible region is appeared. This is the visible light. Okay, and you see Max Planck is proposed the relation between the energy and frequency. Okay, Max Planck is proposed the relation between the energy and frequency. Okay, per unit time number of waves passes through the point, it has a more frequency. Okay, it has a more frequency. So which wave has more frequency? So more waves are crosses the point means at a particular point it crosses the more waves means it is reaches, waves is contains the energetic particle, electromagnetic energetic particle. So more waves, more frequencies, that means more waves are cross the point. So more waves crossing, more energetic particles are crossing, so more energy is to that rays. So energy and frequency is directly proportional to each other. So next E is equals to, the Max Planck is proposed, the constant is Planck's constant, E equals to h mu. So what is h means 6.625 into 10 to the power of minus 34 joules into second. Okay, 6.625 into 10 to the power of minus 34 joules into second. If it is converted into x, 6.625 into 10 to the power of minus 27 x into second. Okay, so this electromagnetic spectrum, we have to learn the electromagnetic fields are perpendicular to each other, it creates the spectrum. They are varies with the entire range of wavelength is differ with their wavelength and frequency from different rays. These all are combinationally is considered as a electromagnetic spectrum. So they are varies with their wavelength and frequency. Wavelength and frequency, they are universal relation, they are inversely proportional to each other. Okay, y means lambda is the distance from one peak to another peak. Okay, frequency is the number of waves passing through a point per unit time. Okay, smaller wavelength wave is more waves are crossing the point. More wavelength waves is less number of waves are crossing the point. So that's why the frequency is inversely proportional to the wavelength. Okay, and next the Max Planck is proposed the relation between the energy and frequency. The electromagnetic waves are, the energy of the radiation is directly proportional to its frequency. If any radiation has more energy means it has a more frequency. So E is equals to h mu, h is the Planck's constant, 6.625 into 10 to the power of minus 34 joules into second and 6.625 x into second. An activity is there in the next coming topic. What is that means? For example, if you take cupric chloride CuCl2 on watch glass, then make it a paste with concentrated hydrochloric acid. Okay, so the cupric chloride is make the paste with the concentrated hydrochloric acid. So next to the platinum loop present in the paste and burn with the non-luminous flame. Okay, burn with the non-luminous flame. So it gives the green color flame. Okay, what is it gives? The cupric chloride gives, the cupric chloride with the HCl paste, that paste with the, we have to collect with the platinum loop, that platinum loop contains this paste, we have to burn it with the non-luminous flame, so it gives a green color flame. Strontium chloride is gives crimson red color flame and sodium vapors gives yellow color flame. Okay, so these all observations, the substances are gives the different colors while burning with the So why? Because the atoms of these elements are different. Okay, here cupric chloride, copper, strontium and sodium vapors. So why that atoms are differ? All atoms are made up of the same subatomic particles only, electrons, protons and neutrons. But that emission of the energy, the emission of wavelength variation is differ with their different colors. So by This is considered as a electromagnetic spectrum. So this electromagnetic spectrum is used to different substances to identify the molecules. Similar how the fingerprints are, we have to use to identify us, we use to identify us. Same like atoms is also has a spectrum by changing the colors. So this is different atoms, different changing of colors is producing here one activity. It is shows the different atoms gives the different colored flames. So this observation is proves all atoms are not same. Evenly they contain the same subatomic particles, but atoms are not same. So that is proves the spectrum, atomic spectrum. That atomic spectrum is different for different atoms, like fingerprints are different from different peoples. Okay, so this is so next you see on Bohr atomic model of hydrogen atom. So hydrogen contains one electron, one proton. Okay, proton are settled at the center in nucleus. Electrons are revolved around the nucleus in definite path. According to Bohr, electrons are revolved around the nucleus in a definite path. This is K shell, this is L shell, and this one is M shell. So which path is near to the nucleus that has a less energy? If it is denoted with E1, which shell, next shell is E2 energy, and next shell is E3 energy. These all shells are varies with their energies. Okay, the energies are represented with the first shell energy is E1. As long as electron in this first shell, it has a E1 energy. As long as electron in the second shell, suppose electron if it is in the second shell, electron has a E2 energy. If electron is in third shell, it has a E3 energy. So E1, E2, E3. So the E1 less than, E2 less than, E3, so on. The shell which is near to the nucleus that has a less energy, the shell which is far to the nucleus that has a more energy. So E1 is the first shell energy, E2 is the second shell energy, E3 is the third shell energy. The energy is going to move away from the nucleus, it has a more energy. So E1 less than, E2 less than, E3, that like so on. So if suppose hydrogen atom has one electron, if that electron is enter into low energetic state to higher energy state, what happened? The energy is absorbed by this electron by external field. So here absorption energy is occurred. If electron is jumped from first level to second level, first level energy is less than second level energy. So when it is jumped from first level to second level, it absorbs the energy by external field. If electron is jumped from second level to first level, it emits the energy. Okay, why? Because here more energy is there, here less energy is there. The difference of energy is emitted in the form of electromagnetic radiation, EMR, electromagnetic radiation. So this like the spectrum is absorbed in the hydrogen atom, that spectrum is the line spectra, emission spectrum. Okay, emission spectrum is energetic lines spectrum. Line spectrum. Okay, Bohr's atomic model is successful for the explaining of hydrogen atom spectrum, hydrogen atom atomic spectrum, but it is not applicable to remaining more than one electron containing the atom. It is only applicable for which atom contains only one electron. Okay, so the next, why the remaining atomic spectrum, how it is formed, the remaining atomic spectrum means the Bohr could not explain the formation of more than one electron containing the atom. Only the Bohr successfully explained which contains one electron in the atom. Okay, here hydrogen atom is there, one electron is there, he is easily explained the atomic spectrum of hydrogen atom, but the more than one electron containing the atom spectrum is he could not explain. Okay, so to modify modifying the Bohr's atomic model, Sommerfeld is introduced the elliptical orbits in the shells. Okay, if suppose it is n equals to 1 k shell, it is one circular orbit, n equals to 2, one circular orbit, one elliptical orbit, it is L shell, n equals to 3, this is the Thor shell, M shell, it has a two additional elliptical orbits. So this like he introduced the elliptical orbits to explain the structure of other atoms. Okay, so Sommerfeld is introduced the elliptical orbits. Bohr is only the circular orbits in the atoms, but Sommerfeld is modified to introduce the elliptical orbits. First shell only one orbit, that should be the circular orbit, and second shell two orbits is there, one is circular and one is elliptical orbit, and third shell one is circular orbit and two is elliptical orbits. So this like the splitting of orbits is considered. The splitting of orbits energy is also splits. Okay, the splitting of orbits, energy is also splits. So it is only one orbit, it has a certain energy. So it is two orbits. Which orbit is near, that is lesser, which is far, that is more. So this like a splitting of orbits is gives energetic also splits. That energetic is produced the energetic lines. So this atomic spectrum is further divided into splitting. So it is a fine spectrum. Okay, it is fine spectrum. This fine spectrum is easily explained by the Sommerfeld by introducing the elliptical orbits. Next one, quantum mechanical model of atom. Electron revolved around the nucleus continuously. Okay, nucleus is made up of protons and neutrons. So around this nucleus, electrons are revolved continuously. So in the quantum mechanical model of atom, simultaneously we can't find out the exact position and velocity of the electron. Okay, for example, if you find articles in dark nights, okay, we see the objects or any articles by using the light. Okay, natural light is there, sunlight is there. By using the sunlight, we are seeing the objects. Other than sunlight, we use the artificial lights, tube lights. We seeing the objects. So without any light, okay, we can't see the articles. So what happened? You find the articles in the dark nights. Okay, what we have to use? Suppose we use the torchlight. Okay, if you use torchlight. So, we can easily find out the particles. Okay. Similarly, in the atom, electrons are very small particle. Okay. Electrons are very small particle. So, to identify the electrons in the atom with our naked eye, it is impossible. Okay. With our naked eye, to identify the electron in the atom, it is not visible to us. Okay. In the atom, the electron is not visible to our naked eye. So, that what we have to do, we use the certain wavelength light, certain shorter wavelength light. We use the certain shorter wavelength light to find the electron in the atom. Okay. So, the shorter wavelength is the means energy is more. So, this light has a more energy. Why? Because it has a shorter wavelength. Shorter wavelength is the means more energetic light. That more energetic light on the atom, the electrons are interacts with that light. So, the disturbances is occurred on the motion of the electron. So, what is said in the Bohr's atomic model, electrons are revolved in a circular orbit. Okay. Definite fixed path, But what happened really means the electrons we are perceiving with a shorter wavelength of light, which has a more energetic light. That more energetic light in the atom, the electrons are interacts with that energy and it gains the energy, and it is disturbances of moving of electron. Okay, the disturbances of motion of electron. That's why we can't find the velocity at the particular point. Okay, velocity at particular point. Suppose here electron is continuously moving. Okay, electron is continuously moving. So, and it is moving not definite path. So, how we find the electron? How we find the velocity of that electron means it is not, it could not find out the electron by quantum mechanical model. So, the quantum mechanical model, the Schrodinger is explained, electron is revolved around the nucleus in a specific region. Okay, that specific region around the nucleus that specific region or space called as a orbitals. Okay, called as a orbitals. Orbit is path, the electron which is revolved around the nucleus. But the quantum mechanical model, the Schrodinger is proposed the specific region around the nucleus. Okay, at that region, the maximum probability to finding the electron in that atom, that space is considered as a orbital. Instead of orbits, electron is where it located in the atom, in the orbital. Okay, orbit is the line which is around the nucleus, but electron is not really revolved around the line. Okay, not, it has a fixed boundary, it has a space where the probability of finding the electron maximum, that space is considered as a orbital. So, these orbitals are introduced by Schrodinger in the quantum mechanical model of atom. Okay, orbitals are the space or region around the nucleus, the maximum probability of finding the electron in the atom, that is considered as a orbitals. Okay. So, in the atom there are the several orbitals is there based on their shapes. Okay, based on their shapes, s orbital, p orbital, d orbitals and f orbitals. Okay, so on. So, s orbitals are spherical in shape and p orbitals are dumbbell and d orbitals are double dumbbell and f orbitals are triple dumbbell, that is not in our syllabus. Okay. Up to s and p and d orbitals you see. S orbitals are spherical shape. S orbitals are spherical shape. So, in the 3 axis it is x, it is y, and this one is z. Okay, that is the shape of s orbital. What about p orbital means? P orbital is dumbbell. Okay, this dumbbell shape p orbitals are along with x axis. It is considered as a px. Along with the y axis, if it is rotated, this is py. Along with the z axis, it is x and this one is y. This is z. This is the pz. P orbitals are dumbbell shape. They are oriented along the 3 axes. Okay, 3 dimensional, 3 axis, x axis, y axis and z axis. Along the x axis, horizontal dumbbell oriented, and at these places, and this like horizontal at these places, the maximum probability of finding the electron, and along the y axis vertical, it is the maximum probability of finding the electron, and along the z axis, the dumbbell, the p orbitals are oriented in the 3 directions x, y, z. So, the p orbitals are split into further px, py, pz. Px are along the x axis, they are oriented. Along the x axis they are oriented as a px orbital, and y axis is py and z axis is the pz orbital. Okay. Okay, for example, you see ma, and this is red color x axis and this one is y axis. Okay, so there is a chances of finding the electron of px orbital. So this like px orbital is, I mean this like it is oriented along the x axis. This is px orbital and this one is py orbital. Left to right px, top bottom py, and front and back. Okay, front and back, this is the pz. So this like in the p orbitals, the orientation is occurred. The maximum probability of electron in the atom is occurred along the x axis px, py and pz. And last one, d orbitals. D orbitals are double dumbbell. Okay, they are dxy, dyz, dzx, dx square minus y square and dz square. Okay, so here dxy, it is x axis and it is y axis. 2 dumbbells, it is dxy. One dumbbell is along the x axis, one dumbbell is along the y axis. And next, it is dyz. Here you see ma, it is appears similarly, but it is x axis and it is y axis, and it is y axis and it is z axis. So dxy orbitals are the 2 dumbbells are along the x and y axis, and dyz orbitals are the 2 dumbbells are along the y and z axis. And this one is the dzx. And next, here sorry ma, dxy means between the axis, between the x and y axis. dyz is between the y and z axis. Between the z and x axis, and dx square minus y square, x and y, it is on the axis, and the last one dz square. It is dz square. Okay, listen ma, it is the x axis and this one is the y axis. So we have 4 separations. It is x and y perpendicular to each other. So we are separated with the 4 separate partitions. So this loop, one loop is this side and this is opposite side, and this side and this one is opposite side. So this is the dx and y. So that 2 dumbbells are between the x and y axis, here, here and here and here, okay. And next to y and z. Y and z means this like dxy. Dxy means one is horizontal and one is vertical. So that 4 places, separation places occur. The 4 loops are spread. That is the dxy orbitals. And next to dyz, you see dyz. Here this is the vertical y axis and this one is the z axis. Now also same. Here one place, here one separation and here one separation and here one separation. In this 4 separation, one dumbbell is between this y and z, and another dumbbell is also between this y and z axis, okay. And next dzx. Dzx is this like, red color is the x axis and z is the, black color is the z axis. It is front and back up here, and this one is the horizontal. So here is also 4 partitions is separated, okay. These 4 partitions, the 4 loops are spread, that is the dzx orbital. And next dx square minus y square means x axis and y axis, okay, x axis and y axis on the axis, okay. The 4 loops are spread on the axis, not between the axis, okay, not between the axis. Dxy, dyz, dzx are in between the axis, and dx square minus y square is on the axis, and dz square is the means the 4 loops, one loop is on the axis and one loop is around the axis, okay. This is the dz. Dz square, you see it is dz. This red side you have seen, back side, front, back one, this is front side. So on this axis, one dumbbell is along the axis, one dumbbell is around the axis, okay. So this like d orbitals are split into 5 d orbitals by their orientation: dxy, dyz, dzx, dx square minus y square and dz square, okay. So these are the orbitals in the atom. The space, maximum probability of finding the electron in that orbitals, okay, s orbital, p orbitals and d orbitals. So in this section what did we learn means, first the spectrum, the nature of the light, wave nature of the light. Wave has a characteristic parameters, wavelength and frequency. The wavelength and frequency has a relation between, in the wavelength and frequency they are inversely proportional to each other. And the next one is electromagnetic spectrum. The electromagnetic spectrum varies with their wavelength and energies, okay. The visible light is, we observe at the range of visible light 400 nanometers to 700 nanometers. The Max Planck, next one is the Max Planck relation is energy with its frequency. They are directly proportional to each other, E equals to h mu. And the next one is the Bohr atomic model. The Bohr atomic model is for hydrogen atom. The Bohr is successfully explained the hydrogen atom atomic spectrum, but in this also the atomic spectrum of hydrogen atom also split into further line spectrum. That fine spectrum is could not explain by the Bohr atomic model. Then next Sommerfeld is introduced the elliptical orbits to explain the fine spectrum of hydrogen atom or other atoms. Okay, next quantum mechanical model of atom. In the quantum mechanical model of atom, in the electron, atoms are very small. In atom containing the electron is very small. That very small electron is we can't find with our naked eye. So we use the high energetic rays to perceive the electron in the atom. At that time, the electron is interacts with that energy. So it is disturbs motion of the electron around the nucleus. So that's why if it is disturbance the motion of electron in that around the nucleus means can we find the velocity of electron at a particular point? No. So, that is why it leads to the space, at a particular space region, at a particular space around the nucleus, maximum probability of finding the electron, not a pinpoint, around specific region, specific space, the maximum probability of finding the electron in that atom, that specific regions are considered as a orbitals. Okay, that orbitals are different with their shapes, s orbital, p orbitals and d orbitals. S orbitals are spherical and p orbitals are dumbbell and d orbitals are double dumbbell. Okay, dumbbell spherical shape is always in 3-dimensional, rotating only same direction. So, that is not split into further. S orbital is only one. P orbital means dumbbell shape. Okay, so the dumbbell shape of p orbitals are along the 3 axis. 3-dimensionalism, 3 axis is there, along the 3 axis they are rotated. So, that is why it is split into further px, py, pz. But what about the d orbitals is means the d orbitals can oriented into, d orbitals shape is double dumbbell, they are oriented into 5 different d orbitals. Okay, first I written on the axis, that is not between the axis. Okay, here 2 axis is means x and y. So, in between there is the 4 partitions is there. This lobe, this dumbbell one lobe is here and opposite lobe is this, and next this dumbbell one lobe is here and opposite lobe is here. So, this is a xy. On the board we can't see the dimensional to 3D dimensional. So, that is why axis we have to change, x and y, 4 loops was between the axis. Next to dyz, dyz means y and z axis between. So, there are 4 loops. This loop opposite is here and this loop opposite here, and dzx 2 axis, x axis and z axis, 4 partitions, this in between the, this loop opposite is here, this loop opposite here, dumbbell. So, these are the dzx, and dx square minus y square means on the axis. They are, these 3 are dxy, dyz, dzx are between the axis, and this one is the on the x and y axis. dz square is the means one dumbbell is on the axis, one dumbbell is around the z axis. Okay, it is only about z axis only, dz square. One dumbbell is on the axis, one dumbbell is around the axis. So, that is like this orientation of d orbitals is dz square. So, that is like d orbitals are 5 different orbitals, dxy, dyz, dzx, dx square minus y square and dz square. Okay. Thank you, ma.